Okay, hey guys, so we're going to do a little video on reaction rates. If you do a rate of something, it's always going to be, for example, miles per hour, or it'll be feet per second, or hot dogs eaten in a minute. So if you notice, all of those, what they have in common are a change in quantity over a change in time. And so in reactions, we measure, this is how we measure the rate of the reaction. Remember the little triangle means delta. You might remember that from math, but it's always of the reactants. It's never of the product. So we always do this for the reactants. And anytime we have the triangle, it's always changes something, which means you subtract. And it's always going to be final minus initial, and that's important because you can have a negative rate of reaction. And for reactants, quite often that's the case. So for example, let's take this equation. Notice that our reactants here are NO2. Okay, so if we did a reaction rate for NO2, okay, it might be something like this. It's a change in quantity. So here's our change in quantity over a given period of time. And notice we have a negative sign. It's important because, again, the rate of the reaction is decreasing. All right, so let's look at some data. Let's go ahead and do our own reaction rate. Now, you might remember back to math. And anytime we do a rate of something, particularly if we graph it, this is what we're talking about. It's going to be a rise over run. And so let's go ahead and measure the rate. So what we're going to do is measure the rate for this particular first interval right here. So here's our first interval that we're going to do. It's going to be this interval right there. That is going to be our change in quantity, and here is our change in time. And so it's pretty straightforward. So what we're going to do is we're going to go 0.0200 minus, it's going to be final minus initial, 0.0147 minus 0.0200. That's going to be our change. And it's going to be negative, obviously. And then we're going to go 10 seconds minus 0 seconds. Okay, so there's our final. So here's our first rate that we're going to calculate. And if we go ahead and subtract that, that gives us a rate of negative 0.0053 molarity. So it's changing in molarity quantity per second. All right, so let's go ahead and calculate the second rate. And the second rate is going to be for these two right here. I'll go ahead and do it over the side here. It's going to be for those two. So that's going to be our second rate. So over here. So we're going to go 0.0166 minus 0.0147. Again, that's going to give us a negative. And then we're going to go 20 minus 10, which obviously gives us 10. So there's our rate for our second. And we got it down here, and there's our rate. So you notice our rate has changed. Okay, so this is like an instantaneous rate of reaction. So you do the same thing for the rate number 3, 4, 5, etc., etc. So you'll be doing something similar like this on your worksheet. You're not going to be doing all of these though. You'll do a few less. Okay, so let's take this. If we calculate the rate of the reaction and we took all of our data here and we plotted it. Let me get my laser pointer. So here's all of our data, okay, and we plot it. So the first slide was how do you calculate the rate of reaction? Next, the second thing you're going to do in your worksheet, you're going to plot it. So what we're going to do here, see we've got time, and here's our time, okay, our x-axis, and then our y-axis, NO2, is going to be right here. So you're just going to simply make a chart of this, okay, and plot it. And I have a worksheet available for you to do that. If you're familiar with, say, Google Forms or Microsoft Excel, or Google Sheets or Microsoft Excel, you could plot it on there as well. It's much easier. We did that in one of our Boyle's Law labs. So anyways, you would get something like this. So if we plotted our first point, 0.0200 at time interval 0, it'd be right there. Our second point at 10 seconds, 0.0147, third point, fourth, fifth, so on and so forth. So notice the rate of reaction is decreasing as the rate proceeds, and that's kind of conceptually that makes sense because you have less reactant as time goes by. So less reactant means that you're producing less product. Okay, so the other thing I want you to notice is this right here. This is the slope. So if you remember in math how we calculate the slope is always going to be the rise, which in this case is the change in concentration, over run, which is the change in time. Okay, so y2 over y1, y2 subtract y1 over x2 subtract x1. Okay, so very exact same thing we do in math, but I also want you to see that the slope is the reaction rate. Okay, so you're just going to plot it, and it's going to look something like that, an exponential decay. Okay, last couple things, a little bit about collision theory. I want to talk a little bit about elastic collision versus an effective. An elastic collision, first of all, is simply when two molecules collide. What happens? So, in order for a chemical reaction to take place, when they collide, two things have to happen. So an elastic collision is when the two molecules collide and just bounce right off one another. That's not going to produce a chemical reaction. So we want an effective collision. And there's two things that has to be. First of all, there has to be enough energy when they hit, because we're talking about when they hit, they have to break bonds. And so when those molecules hit, we have enough energy to break those bonds. The second thing is they have to have a favorable orientation. So you can imagine two shapes and that fit together kind of like a lock and key. So those shapes can hit and hit and hit, which represent the molecules, and yet if they don't hit in just the right orientation, they're not going to produce a chemical reaction. So for example, two molecules might hit, but that collision needs to take place in the middle of the molecule so that the bonds break there. Or a different molecule, that might need to take place on the end of the molecule. So, all right, so you guys are ready to try that worksheet?